Hi ladies, this is Mrs. Blaufuss, and today we're going to look at postulates and conjectures. You have a few terms, so this is what your note sheet should look like. I'll zoom out here so you can see. But we're going to go through a few different postulates and then give some examples of those postulates. And then we're going to also work with if and then statements, which are conditional statements. So we'll define that a little later in the lesson. And then we'll give some counterexamples and converses of those conditional statements. Okay, so to start, we're going to look at the term postulates and conjectures. And a postulate and conjecture is just a statement that we believe to be true. So we can't find any counterexamples of this statement, meaning we can't find any examples that disprove the statement. And so it's something that we believe to be true. So we use postulate and conjecture kind of interchangeably. In this class, we use conjectures. That's what our book uses as our given statement or the statement that we believe to be true. But in other textbooks and examples, you may hear the term postulates. Okay, so the next piece is actually defining one of these postulates. And the first postulate we have is that two distinct points form a unique line. The second part of this postulate is that there is only one line that goes through two distinct points. Any two given points will form one unique line. This line is line PQ. It is the same as line QP. Okay, these are the same line. The next postulate that we have is that the intersection of two lines, so in this case, line M and line L, intersect at a unique point. In this example, that unique point is P. So again, in this case, line L and line M intersect at point P. And then the third postulate that we have for this lesson is that 3 points determine a plane. And the second piece of this is that there is only one plane, one unique plane that contains 3 distinct points. So here is my plane. This plane is a flat surface. It's two-dimensional. It has no thickness, and it's made up of 3 points. When two planes intersect, so if I imagine this other plane with these 3 distinct points, and I'm just going to draw this plane as dotted. The intersection of those 2 planes is a line. So I can see that these 2 planes intersect. This point, I'm going to call it point A, and this point, point C. They are not on the same plane, but points B and point D are on the same plane. So the intersection of those 2 planes is line BD. On your note sheet, you should see these 3 points, points D, E, and F. And these 3 points are non-collinear, as you can see. Let's name all the different lines that we can draw through these points. So remember, it only takes 2 of these points to form a line. So we can draw one line through ED. We can draw another line through DF. And then we can draw a third line through E and F. Now we only have 3 lines, and let's name them. So we have line ED, and that's the same as line DE. Okay, so those are not 2 separate lines, it's the same line. So lines ED, line FD, which is the same as line DF, and lastly, line FE, which is again the same as line EF. Okay, so there are 3 lines that we can draw through these 3 points. Now, looking back at these 3 lines that we drew, the next question on your note sheet is, what is the intersection of lines FE and ED? Okay, so here's line FE, it goes through point E, and here's line ED. It also goes through point E. Remember that the intersection of 2 lines is a point. So name the intersection of line DE and EF. That's point E. Okay, the next example is about naming all of the planes. And this is point A. Can't quite see it here. So this is a 3-dimensional figure drawn on a 2-dimensional surface. So we need to kind of imagine what this would look like as a 3D object. And to classify this object that you see on your note sheet, it's a triangular pyramid. Okay, so all 3 sides of the triangular base meet up here at point G. I'm going to just shade in the sides so that you can kind of imagine. This is one side. Here's another side, and these are both sides that you can see. But on the back, you see this dotted line. That indicates a side that's not visible. Okay, but it's all one side of the triangular prism. Pyramid, triangular pyramid. And then there's also the base. Okay, so that whole part is the base. So you're not just counting the sections, you're actually imagining it as a 3D surface, and we're going to name all of the planes. Okay, so the planes again are a group of 3 points. So here's one plane, CAG. Plane CAG. Here's another plane, plane GAH. It doesn't matter which order you name the plane in, as long as it consists of 3 points. Okay, so plane GAH is the same as plane AHG. It's the same group of 3 points. And then here's the third side of the pyramid, plane CGH. And then lastly, we have the base of the pyramid, and that's plane CAH. Now you can see in this diagram that the planes intersect several times. So plane CAG intersects with plane CG, plane CAG intersects with plane CGH. Okay, so these planes, although they're not drawn to go on forever, they do. And when they do intersect, they form a line. Okay, so remember that the intersection of 2 planes is a line. So let's look at this next example. It asks you to name the intersection of plane CDG. So let's find that plane. CDG. Okay, so that's going to be the top of our box. And we're looking for the intersection of this plane and plane BCD. So here's plane BCD. That's going to be the side of the box. So when 2 planes intersect, they form a line. And in this case, here's the line that we see. Okay, that's the intersection of those two planes. So we can call that line CD. Or we can write it like this, with the symbol for line. Okay, and then the final part of this lesson is the if and then statements. They're called conditional statements. So an if-then or conditional statement has two pieces. It has an if part and a then part. If you see these abbreviation IFF, that means if and only if. And in an if and only if statement, it means the first and the second part of the statement are true, and it's true if you reverse the order of the statement. So an if and only if statement is a conditional statement, and the converse of that statement are true. The converse of a conditional statement switches the if and the then portion of the statement. The if part is the hypothesis, the then part is the conclusion, and the converse switches that. So it says if the conclusion is true, then this hypothesis also has to be true. Okay, so let's look at an example. So let's say that if you are a DSHA student, then you wear a school uniform. You are a DSHA student is the hypothesis. You wear a school uniform is the conclusion. So if you are a DSHA student, then you wear a school uniform. That's true, but is the converse true? So the converse switches the if and the then statement. So the converse would be, if you wear a school uniform, then you are a DSHA student. So this is the converse. And we know that this is not true because there are other schools that require you to wear a student uniform. So in this case, we would not use if and only if. We only use if and only if both the conditional statement, and the converse of the conditional statement are true. So please jot down any notes or questions that you have and bring them to class, and I will see you next time you're in class. Thank you.